We're going to do a little experiment this afternoon, and that is to just see how well this burst sleeve will suppress a punctured or failed hydraulic hose under high pressure. Okay, this evening we're discussing hose burst sleeve, also called hose abrasion sleeve. There is ways to fit this properly onto a hose. We're going to show you the way we do it here and some of the tricks that we use to make sure that it's going to fit well and also allow the hose still to flex through its full bend radius. Anyway, moving on down here. So this is a tightly woven textile sleeve. I've just cut and trimmed this in preparation to put it over a hose, but to prevent fraying, I've just scorched and melted the ends so that they don't continue to fray. These are Aluminium Ferrules. They actually started life as a long aluminium tube, and we've just had a company cut these into the desired lengths, and they're meant to actually crimp over this ferrule here, but with the sleeve underneath. Now, what's its main purpose? Main purpose is if for some reason this hose fails under high pressure, instead of a jet squirting out and either hitting someone in the face, or if someone's hand is close by or someone's arm's close by, under pressure it will actually penetrate the skin, and once it penetrates into the skin and into the body, you then need surgery. Yeah, you need to go to the hospital and they'll actually cut you open, and they will leave it open for a few hours with some special absorbent pads. They will then close it up, leave it for 24 hours, and then come back 24 hours later, cut it back open again, and then check again if there's any oil still left in it. It's really, really dangerous. Yeah. So what's this meant to do? It's pretty much mandatory on most construction sites now and most mining sites in Australia. What it basically does is suppresses the injection. So instead of there's being a very high pressure, high velocity jet, it will fill this whole bag, if you like, with oil, and then it'll just weep out rather than shoot out under high velocity. So we're preparing some textile sleeve for a hose. Once we've cut the hose, we need to actually stop the ends from fraying, so we just burn it a little bit to melt the weave so it doesn't continue to fray. We've got these aluminium tubes, or sleeves as we call them, or ferrules, aluminium ferrules, that we specifically had sized to fit nice and neatly over the hose fitting and the hose sleeve. So what I'm doing now is slowly lining up one end and sliding the sleeves on. They can be a bit tight to get on. The issue is you've got to allow a little bit of slack in the sleeve for when the hose actually bends. So what I'm feeling for now is where the actual hose fitting finishes and the thread starts, and then I'll actually cut it to give me some room. Shells, we line up the shells over the sleeve so it's nice and tidy, and then we crimp the shell onto the sleeve quite firmly, so it actually is quite a tight, neat assembly. we do the same with the other end. What I'm trying to show here is that as you bend the hose, the sleeve actually shortens and pulls back. So we need to allow for that pull back when the hose is bending. That's why when the hose is straight, the sleeve looks a bit wrinkly on the hose. You can see it's a bit fiddly, and I'm a bit fussy, so I'm continuously trimming and stuffing around. But things need to look good if people are paying for stuff. So that's it. That's one hose assembly done. This will prevent jets and sprays, and it will convert jets and sprays into just an ooze through the weave. So the sleeve comes in 50 metre rolls. Obviously people don't have to buy 50 metres, but this is how we buy it. So depending on the hose diameter and also the size of the fittings, depends on the size of sleeve you will use. Obviously bigger hoses, bigger sleeve. We're going to do a little experiment this afternoon, and that is to just see how well this burst sleeve will suppress a punctured or failed hydraulic hose under high pressure. What we expect to see is we've got a brand new hose assembly here, specifically made for test purposes. This is an Engimatech 100 SAE 100R2 half-inch hose rated to 4,000 psi working pressure. We're probably going to put 3,000 psi as a test pressure today. We're going to pressurize that to 3,000 psi so that everybody can see that the hose is fine. We will then drill a small hole, mount it in the vise over there, and then supply another 3,000 psi of pressure, and we'll see just what a small hole, what oil will look like escaping from a small hole at 3,000 psi. It could get a little messy. Hopefully we'll be able to get it on film. I haven't done this before, so it'll be a bit of an interesting experiment. We will then take this same hose and put a sleeve on it, put some aluminium collars on it to locate this sleeve, so the only way the oil can escape is through the tight weave itself. So it should, theoretically, suppress the jet, and it'll just supposedly ooze out through the weave. So this is the theory, this is what the manufacturers say it will do. Let's prove it. So, this is our pressure gauge here. It is upside down. I could actually mount it the other way. I might actually do that, but we've mounted it upside down so it doesn't get in the way and doesn't get knocked. It's already oozing from the back pressure. It's already oozing from the back pressure. We're using an open centre valve here. I'm going to put a bit more power because generating 3,000 psi actually requires a lot of horsepower. I'm going to do this very quickly because of system back pressure. Now I may even break the drill doing this because, you know, I'm trying to push a drill through high tensile braided steel. It's not going to spray because it's not under pressure now. So let's give it a go. I might break the drill. Like I said, I might break the drill, and I did. Alright. We've drilled a tiny little hole. Actually, we pushed a 1.5 millimeter diameter drill into there. So it'll probably start to ooze straight away as soon as I start the pump, because there is a little system back pressure. Even though I made a hole, it looks like it's self-sealed. Bigger hole, because if the hole is just with a 1.5 millimeter hole, the pressure looks like it's just self-sealing the hole. So we'll go to a 2 millimeter hole and a 2.5 millimeter hole until we actually get something to leak. So this is another advantage of our Engimatech branded hose. It kind of self-seals itself if the hole is small. So we've got a series of drills here. So we did start with a 1.5 millimeter. We'll go to a 2 millimeter drill and see what effect it has, if any. The idea is we want to try and generate a spray of oil coming out. Obviously we're trying to replicate a failure. Now whether that failure is from mechanical damage because the hose has been pinched, or a rock's fallen on it, or just fatigue and the steel wires have actually failed. So we'll try with a 2 millimeter drill and see what happens. Angle this a little bit away from us so that it sprays in that direction rather than straight up into the air. So there's a 2 millimeter hole into rubber, so rubber tends to sort of flex and stretch, and then when you pull something out it closes back up. So let's give it another go. Effect. So that was actually quite impressive, but that's generally what happens out in the field. So we're now going to take this hose and we're going to actually sleeve it, put some collars on it to contain the oil inside the sleeve, and then let's see what happens. Just film me disconnecting it. Ooh. First I think we need to clean up the floor a little. So we're going to sleeve this hose in this woven textile, and we're going to actually use these aluminium sleeves to tightly hold these sleeves onto the hose. So the other thing I've done is that's where the hole is, and I've made a tiny little mark there so that we know when we actually pressurize it, we won't be able to actually see the hole, but I'll be able to, with that mark, locate it correctly so that when we actually repressurize it with this sleeve, we'll know where to be looking to see if we're going to see anything. All right, so there's our mark. So the hose is back here somewhere. So this is now holding this sleeve on really tight. So the only way the oil can leak, it can't actually get under there and leak out this side, or it shouldn't be able to. It might a little bit, but what we want to see is, where's the mark? There's the mark. And the hole is under there somewhere. All right. It's already leaking there, it's already full. There's the mark, so the hole is about there somewhere. You might want to come from this angle. Dylan, otherwise right, put some power. See the sleeve sitting up? There's that pressure. The spray is totally suppressed. So it's done its job. Yeah, it's done its job really well. You can feel that's just full of oil, but so this is the purpose of this woven textile sleeve. It's meant to protect operators from high velocity jets, because all it's done is actually, it's just absorbed all the energy. The other really important factor is that you don't have a spray or a fine mist. A fine mist spraying on a hot exhaust manifold or a hot turbine on a turbo, a fine oily mist on a red hot turbo that's been operating all day is a recipe for fire. Yeah. So this will suppress all that mist and just create, a very localized leak rather than it going everywhere. Obviously, you're protecting property as well. If this was next to a brand new $1 million house and an excavator blew a hose, the last thing you want is hydraulic oil all over this newly completed home. So, it's done its job. I'm actually quite satisfied with how it works. Hope you enjoyed this one. We had a little fun making it. And we'll see you on the next one. Don't forget to like and subscribe. We'll see you soon. Bye for now.